Welcome back to the sixth video about my electronic dual power lever engine control IP68 contraption. In the last video we made these handles that obviously replace those Lego parts here in the real thing. In fact, we only finished one handle in the video and I finished the second handle offline because, well, it's exactly the same. Card here, link in the description. This time I want at least to start with the levers here made out of aluminum. Enjoy! So we are talking about these parts here from the side and from the front, and I already told you in the last video that I made a detailed drawing of the levers and the handles. And here's that detailed drawing again with all the scribble I made on it while fabricating the handles. So now let's have a look at the details of the levers. As you can see, I've drawn in here some more details, but let's start with the basics. So our main dimensions are 18 millimeters width and 5 millimeters thickness and a length of 104 millimeters. And then we have here 1, 2, 3, 4, 5 holes with a diameter, 6, that's an error, 5 holes with a diameter of 12 millimeters, and then here at the end for attaching the handle with a screw we have a hole of 5 millimeters which will be threaded with M6. And of course that first hole here, that's the one that goes over the shaft. So we have also here a little hole going through, and the bottom part of the hole that will be threaded with M2, and the top part of the hole will be just drilled through with 2 millimeters. And initially we just drill through with just 1.6 millimeters, so we can thread here, and afterwards we make a little cut here because this is meant to compress that hole around the shaft. And finally we make we extend the hole at the top by 2 millimeters. Anything else? A little pocket here that we have to mill out for the screw head. That's about it. Okay, here we have to mill a radius at some point. So it's, fits nice in the hand with a round handle behind it. Here's the aluminum stock I will be using for the levers. It's 5 millimeters thick, so we won't have to do anything in that dimension. Width is 20 millimeters, so we will have to take off 2 millimeters in that dimension. By the way, that was in a mailbag card here, link in the description. And I need, of course, 2 pieces of that, each a little bit longer than 104 millimeters, because I want to have some materials left in the end that I can mill off to get real nice faces. I will first try that on my little table saw, though in the past I had one very bad experience about sawing aluminium, especially with that blade on that saw, but that was an aluminum heatsink, and hopefully that aluminum alloy will behave a little bit different, just in case I have some cutting oil here on. No, absolutely no luck. You can probably see that here, but the teeth get immediately smeared with smeared close with aluminium. So let's stop here and get out my manual saw. So the cut is already started, of course, down there. Maybe you can see it. With the table saw. I have a very professional stop, so the second piece will have exactly the same length. So let's get over with it. There's nothing like the smell of cutting oil and aluminum chips in the late afternoon. Here are my 2 pieces of aluminum stock, and they are approximately, a little over 108 millimeters, so exactly where I was aiming for. And now, because I don't want to repeat each and every operation for both pieces, we will glue them together. And yes, I cleaned up the cuts with a file and roughly cleaned it with some alcohol to get the cutting oil off. So I give both surfaces one last good wipe with the alcohol. And let that dry off. Okay, no more fingerprints. Then this is just for aligning the stuff. I wet one of the pieces. That's important when you use super glue and it doesn't come in contact with air. Then you need a little bit of water, not much, just a little bit of water to activate it. And here comes the super glue, hopefully. As always, it's clogged. But now here comes the super glue. And now one on the top of the other, nicely aligned. A little pressing. And just to be on the safe side, we clamp this together. Can still align it a little bit. Okay, but now it's starting. And now we wait. The moment of truth, about 1 hour, 20 minutes later. Well, it seems to be holding together. It's nicely aligned. Perfect. Next step. And that would be to mill the 2 pieces to the final major dimensions, 104 millimeters by 80 millimeters, on my milling machine, which I just freshly aligned. Card here, link in the description. I'm using 2 parallels here to elevate my workpiece, or my 2 workpieces, a little bit, so that they actually, stick out of my vise. And I try to center everything up so I have enough space on the left and the right to mill down the faces, and then we can start milling. Let's first clean up the long faces here, and afterwards we turn it over and mill it down to the 18 millimeters on the other side. So I'm going down until I'm just touching. Then I go out. And then I go down a tenth, let's start with a tenth of a millimeter. And this will be, of course, a tedious operation. Then I move over a bit. And back we go. And we should have a nice surface here now. Maybe not too perfect. I will do a second run, another 10th millimeter, but I won't film that. It's unnecessary, I think. I actually did, an S3 passes because, that mill bit is only 6 millimeter in diameter, so I made an outside pass and then directly at the center, and then again an outside pass here. But I think we have now a nice and shiny surface. And now we mill here the one end. Sorry for the earthquake, so just touching off here. And then we do 1/10 of a millimeter. I have to change my strategy. Obviously, there's not enough meat here, that is length, in my mill bit to mill the whole height here of the face. And I changed my strategy in between and just went one pass on the top and then lowered it and made one pass on the whole face. But as you can see, it's not working out. It's not working out. So we will, for the faces here, we will turn the whole thing 90 degrees in the vise and then turn them down. So we will continue now with the opposite long side after I cleaned everything up. I deburred the piece, cleaned it, flipped it over and put it back into the vise, and I changed a little bit my clamping approach here. So you see now here on the movable jaw, I'm using a little shaft here. So the piece won't, and I suspected that it did that. I have no proof for that, but because we are clamping it only here at the very top of the vise, I had the feeling that it was a little bit, finger in here, leaning over to that side from all the asymmetrical pressure. So I tried to avoid that by using that shaft here on one side for clamping, and this surface here of the vise, that should be, absolutely plain. Okay, let's take off another, I guess, 1.5 millimeters or so. And because I really don't want to do 15 passes here over and over again to get down to my 18 millimeters, we'll try to take off a little bit more this time. To be exact, after we have contact, we'll try to take off, let's say, 2/10 of a millimeter and see how that works out. Now, that worked in 2 passes, and there's a burr here at the edge, but it's really just a burr. So I don't really, zooming out, I don't really have to do an S here. So 3 passes in total for one run. This is just the burr here. And the finish looks, acceptable. Okay, now let's try 0.4 millimeters. Double that, what we just did. So 0.4 millimeters, zooming in again for your viewing. And that is in the way, but I guess it will come down again due to the vibration. There's not much I can do about that unless I try. Okay, I clamped it. Can you see that in the camera position? Yeah, here. I clamped it out of the way. So, yeah. Let's try that again with 0.4 millimeters. Yeah, I'm slowly but surely getting into it. Okay, I don't think I need to film that anymore. I will probably increase to 0.5 millimeters in one go and mill that down to, I don't know, 18.5 millimeters or so. We are currently, and I'm measuring here at no burrs, I hope, at the far end, currently down to, well, can you read that? 19 point something. So yeah, I will go down to 18.5 and then we turn it around again and finish the other side. Same game, cleaned everything up, deburred it, put it back in the vise, after flipping it around of course. And we're down to 18.4 millimeters. So I will touch off and take an 0.2 millimeter cut and then I will measure again at both ends where we are and then I make a finish cut. But yeah, I think you saw enough milling action, at least, yeah, this operation in one video. So I will stop that now. 18.0 millimeters sharp, or well, maybe 18.05 maybe. Anyway, good enough. And the finish, yeah, well, not too shabby for a well, basically cobbled together milling stack. But now we will have to mill that down to a length of 104 millimeters. Once again, I used parallels to elevate the whole thing here to that portion of the jaw here that is wide enough to hold the piece. And again, the piece is pivoting a little bit here in that plane. So when I closed the vise, the parallels came loose, but I don't care about that here because, yeah, that angle here is not really important. Okay, let's touch off and take a little bit off here, 1/10 of a millimeter or so. Okay, I do the same thing on the other side, so we have a nice surface and then we measure how long that thing actually is and how much we have to take off. I can't really give you a better shot here, but we're currently, with both faces cleaned up, at 17.6. So we have some ways to go. Let's see how taking off 0.2 millimeters works out for me. Besides getting all the aluminum in the face, that was nice. So let's try 0.4. Okay, more than 0.4 is suicidal, I guess. So yeah, I will work my way down now and then we return to the other side and bring that to 104 millimeters. We're down now to 105.8 and I was getting danger close here on the far side to the vise. So I'll continue now on that side with milling off stuff until we are at 104. 104 millimeters, exactly. And the finish, let me focus on that. Yeah, it's, I guess, also not too bad. It's time to get back to the drawing board and mark the most important lines for all the holes here on my workpiece. And you see I already blackened the areas of interest. I will do this using this. Yeah, I actually had that somewhere stored away. Vernier height gauge, or simply height marker. I'm not quite sure what the real name in English for that thing is. Tremble, I heard. I don't know. Anyway, and I will using this wooden plate, which is the smoothest, evenest surface I own. I know that should be done on a precision ground table or at least plate, but yeah, that thingy is what I have. When working with these things, I always like to lie them down on the side to look at the scale. Just my personal preference, but as you can see, we start with 9 millimeters. The 9 millimeters are, of course, the center line of our piece, which is 18 millimeters wide. And then one by one, we will mark perpendicularly the centers of our 5 big holes, measured from that edge. And then we will finally mark the hole for attaching the handle, measured from this edge. So all I have to do is, with some reasonable force, scribe the line here, and we should have our center line. Nice. Okay, so that's not a line for the holes, but as long as I'm in this orientation, that's 2 millimeters above the ground. That's basically somewhere where we will mill down later on a little pocket for one of the screw heads. Just so I don't forget that. Okay. Yeah. I mean, it's not a critical dimension. It's visible. 3 more lines also for the pocket we will mill out at the end. Not critical, but I just have some, I would like to have some orientation how deep I need to mill. So basically at the end we're just milling out that little edge for a very little M2 screw head. And just so I could hold on to that thing a little bit easier, I clamped on my 90-degree angle here. Keeps me also true here at the 90 degrees. So I won't mess up. So this is now 11 millimeters for the first big hole. 27.2 second big hole. 43.4 third big hole. And yeah, these dimensions are not really critical. Fourth hole, 59.6. Fifth and last big hole, 75.8 millimeters. And now we need to turn the thing around, because in my drawing I have the distance here to the hole for the handle measured from that edge. And that's again at 9 millimeters. Finally, we need some scratches here. That is one scratch along this side and 2 scratches here, because remember, these are 2 handles for the center of the little M2 screws that will press everything together around the shaft. So I hope I'm here at 2.5 millimeters. Looks fair enough. And now we need 2 scratches in this dimension here. one on one workpiece. That should be aboutish the center. It's hard to see. Yeah, I give you that. And the other way. I marked everything, so our 5 large holes and the small hole here on that side. That little edge we will mill off to take on the M2 screw head, and the centers for the 2 M2 screws that will later on clamp everything together around the shaft. We're back in the mill. Yeah, I put my workpiece back into the vise using parallels. Yeah, there's still the issue that it might not absolutely correct here in the plane with the angle. But then I had to remove my parallels because otherwise I will drill into them for the 12mm holes. Anyway, I'm aligning visually a little center drill here on a marking until I really think it's on the spot, and then I will lock that axis. I'm doing that online, off camera, on the compound table. Yeah, looks good. Still looks good. And then we do the same thing for the other dimension here. And you can see from that perspective here, yeah, sorry for the earthquake. We can add a little bit, maybe a little bit more. And then just to be on the safe side, we can make an imprint. Okay, this should be pretty much the center now. Okay, locking this axis too on the compound table, and then we do our center hole. Okay, looks good. And then, without changing any settings here on the compound table, I'll change it over to a 5mm drill. That will be the final size for that hole here. And, well, then we drill. Just wanted to remind you that we're going here through 10mm of aluminium. And that I will repeat now, that I will now repeat for all the holes here on that side. And I don't think will have to film that, will I? One more remark. If my milling stack is set up correctly, then along that axis, or better on this axis, I won't have to make any corrections in regards to the position, because we should be moving completely parallel. Just making a dent here again. Completely parallel. So the only corrections I will have to make is in this direction here. So for the second hole I made that correction here, and yeah, the bump is directly on the line. The other thing beside it, that was my first try. And now I did something that I didn't want to do. I actually broke my center drill. Yeah, and I was not quite on the line, but as I said, that's not so critical. Difficulties. Challenges. I totally butchered that hole here trying to drill out that tiny tip that broke off my center drill, and I killed two other drill tools by doing that. So we leave that little catastrophe here aside, and I move on and show you what I wanted to show you here on the next line. Okay, new center drill, a little bit bigger and sturdier for the drop, and if I go down now, you see I'm hitting here exactly on the spot. Perfect. It might seem, whereas the other end of the broken one, from this perspective, that we wandered off, or that it's not really centered in that direction, but that's an optical illusion. And since our vise, our compound table is going exactly parallel in that direction here, we don't have to readjust in this direction each and every time. It just is enough to adjust in this direction here. I'm still a little shaken as you from that thing here, as you might be able to hear. Now we have all, but of that one, 5mm holes in on that side. And now it would be time to widen these 1, 2, 3, 4, 5 holes up to 12mm. I won't probably try to do that with that atrocity here, but let's try that with these 1, 2, 3, 4. And I won't try to go from the 5mm pre-drilled hole directly to 12mm. That would be suicidal. But I will first use that 10mm drill that is already here in the mill. And after that I will change hole by hole to the 12mm drill. The problem here was to get the 10mm drill and subsequently the 12mm drill in. I had to move the head of my mill. So our alignment on the center line might be a bit off now. So we have to readjust this axis here. And also I will have to recenter the drill on each hole in this axis here. I'm missing the right tools for that. There are better ways. I'll have to improvise a little bit. Centering that 10mm drill on the existing hole without any tools is really tedious. So what I'm doing here, I'm just advancing it a few tenths of a millimeter, and then I'm scratching the edges of the tool, and I'm moving my axis to the left and the right until the scratches on the right side appear to have the same size as the scratch on the left side. And as you can see, I'm almost there, maybe half of a hundredth more. And I'm turning by hand, obviously. And of course, I'll do that now also for the other axis because, we moved our head. So we are no longer on the center line. Okay, I already adjusted the other axis, so you can really nicely see that basically the scratch or the counter sink on the left side is exactly the same depth as on the right side. That's how it's supposed to be. Let's do that hole here with 10mm. And I slowed down the spindle considerably. Now, beside the chatter and the noise, that was not too bad. Now I have the 12mm drill in, and I will go even slower with the spindle, that is. Or maybe I give it a little bit more juice. Or maybe I give it a wee bit of cutting oil. Okay, something overheated and currently my spindle isn't turning anymore. Yeah, I'll come back to you. We're back in business. I have to admit that spindle is not specified for 12mm drilling. And we're in cool down again. And we're in business again. Side note, it's not the spindle motor up here that's overheating. That's cool as a cucumber. It's actually the transformer in the power supply. I think I'm out of cards, but for the teardown of the power supply, link in the description. And we are through. Wow. Okay, first hole. 1, 2, 3 more to go, and yeah, later on we will have to take care of that thing. This is really not my day. So while drilling the with the 12mm drill, the second hole, the two pieces separated in the vise. I will still do the third hole because this is also uncritical. That's just getting some material off to make the part a little bit lighter. But these holes here, that hole here at the end, that is critical, and I won't do that in this unstable state of affairs. Third hole is done too. It went quite smoothly. I didn't need any cutting oil or any cool down period, so that was good. On the other side, it continues to be a bad day because I was, yeah, the hose is not connected, but yeah, cleaning here and also on the bench with my vacuum, and suddenly I heard a very distinctive thud as something was sucked up, and yeah, I don't know what it was, but it was massive. I don't see anything missing here on the bench, or do I? I see something missing. Something like that. The whole case. I will take that now out of the vise, and then we have a look and a think. So yeah, 12mm holes are definitely beyond what that little mill can actually do. That was our first 5mm hole, and then that was where I made a mistake. And here we have our 3 12mm holes that I was still able to do. Well, I got the separation here at the second hole, but anyway, I did the third hole too. But as I said, these are not critical. This is also not critical. This is just to make it look a little bit more transparent. That is the important hole where the shafts will go through later on. So yeah, I need to think about that, and I need to also to think about this. And if we look at the inside where the two pieces were glued together, that looks that was the first hole where they were still together, and then these are the second and third hole. Okay. As I said, not my day. I guess I stop at this point and yeah, start cleaning up messes, amongst other things, digesting the back inside my vacuum to find out what it swallowed. Anyways, I cleaned up the parts a little bit here, and yeah, okay, this was the inside. You still see there the super glue. We have to get rid of that now because gluing them back together is not really an option. Yeah, and that's not too bad. It just means more work for me because some stuff I have to do twice now. So drill these two holes here and then drill here another 12 millimeter hole and take care of that atrocity here. And I guess the simplest way is to, yeah, try again to drill it from the back. And hopefully that little sliver of hardened tool steel from the drill will just, yeah, be pushed out. Yeah, so till part 2 of the levers. Bye.